What is the OSI model? Also known as the OSI reference model, it separates the technologies used in networking into 7 different parts, also called layers. So you might or might not have heard of people saying things like, hey, that's a layer 3 issue or a layer 4 issue. The 7 layers of the OSI reference model, starting from the lowest layer, are number 1, physical layer, number 2, the data link layer, number 3, the network layer, then you've got the transportation layer, the session layer, the presentation layer, and then the application layer. That's very difficult to remember all at once, so people came up with a popular mnemonic, which is please do not throw sausage pizza away. So hopefully that helps you memorize the different layers a little bit easier. Now, the layers are usually represented in a stack that looks like the following. Now, you might be wondering why 7 layers in the first place? What do they do, and why is the image starting from the 7th layer instead of the first layer? Don't worry, we will discuss these layers in a little bit more depth in this chapter, but also we will discuss them even more in depth in future chapters. But for now, we need to cover other introductory topics. There's also something called a TCP IP model. So what is the TCP IP model? Well, just like the OSI reference model, it separates technologies in layers, but the TCP IP model only uses 4 layers instead of the 7 that we just saw. And depending on the source, you can also find this model referenced as the TCP IP stack or Internet Protocol Suite. These are the 4 layers of the TCP IP model. You have the application layer, transport, internet, and then link layer. The TCP IP model was developed before the OSI model, but by the time that the OSI model was finished, the TCP IP model had already gained traction and acceptance from different organizations like the Department of Defense and IBM. The TCP IP model became the standard for modern networks and is the model that we all use now in modern internet. But the OSI model was also used to influence the improvement of the TCP IP model, and it's still used for academic purposes and as a reference model. The OSI model is so prevalent, in fact, that in the IT field, when we refer to a layer with a number, like layer number 7, we are referring to the OSI model and not the TCP IP model. But both models, in general terms, are really not that different, so it makes it even more complicated. But here's how they compare to each other. As you can see, the first 2 layers of the OSI model, being the physical and data link layers, are equivalent to the link layer on the TCP IP stack. Then the 3rd layer, the network layer, is equivalent to the internet layer. The transport layer stays the same, and the last 3 layers, being the session, presentation, and application, are merged into one single layer called application. Since this is a networking fundamentals course, we will be covering from layers 1 to layer 4 on the OSI model. We'll also just briefly touch on the other 3 layers, but we won't go into depth with those for this course. So why do they exist in the first place? What's the point of these models and these layers? Let's use the same example from our introduction where you are watching a video right now. But to explain why the models are needed, let's imagine that you have a video library stored on another computer. So you connect your personal computer to the other computer storing the videos using an Ethernet cable since you have physical proximity to it. Think of this as the smallest network that can exist, a network with only 2 devices. Or think of it as your computer being a client and the other device being a server. This is called a client-server architecture. So communication here is pretty easy. Sure, you do need to set up some quick configuration to share folders and files, but once it's done, you can share files and information quickly. But after this, your family also wants to have access to your video library. So some of them have their own computers from other manufacturers, some connect via wireless. Maybe they also need to access the video library from a different room of your house, or even an entirely different house. So your home network starts to grow, and now even your neighbors are asking to have access to your video library. So you end up with something that looks like this. That's a pretty big infrastructure, and you made a big investment. But here's an issue. You've bought network devices from different manufacturers, and each vendor uses a proprietary stack or model, and therefore it can't speak to other devices. Maybe your customers or partners are using a different brand of computers and it's impossible to communicate with them, so you can't properly use the advantages of networks. There is zero interoperability, which is a difficult word to pronounce, meaning that there is no ability for computer systems or software to exchange and use information. That's why organizations like the IETF, which stands for Internet Engineering Task Force, and the ISO organization, which stands for International Standardization Organization, develop standards, the TCP IP model and OSI model, respectively, to guarantee the communication between different devices, regardless of manufacturer. And so that way, regardless of what vendor you choose to use, there are no problems in interoperability. That's why you can have one brand of computer connected to a Wi-Fi router from a completely different vendor to still access the internet. You can kind of think of it as languages. In the past, every company created their own language for network communication. But as new technologies emerged, the devices using these new technologies were not able to speak with other devices. So the model gives us a neutral language that all devices can speak. And with this new language, you can grow your network as much as you want, regardless of what kind of devices your family, friends, neighbors, customers, etc. have, as long as the devices comply with the standard, or should I say, talk the same language. Okay, now that we've covered why these models are needed, let's go ahead and complete this lesson and move on to the next, where we will explain each layer in more detail.